All right, in the next part of the question, you are told to find an approximate expression for this indefinite integral that we mentioned earlier. The approximate integral expression technically is for ln cosine 2x, right? Because you already found the Maclaurin's expansion, which will approximate this particular function in part 1. So what we do, right, is to replace, right? So this should be approximately, all right, the expansion for ln cosine 2x, all right, with what we had earlier on. So this expression, right, came with this. All right, and then when you divide it by x squared, this is the resulting uh, integrand that you have. Okay, and then you integrate it, and you get this particular expression. This is quite simple. Okay, then the next part of the question just says to ask for an approximate value for this definite integral, giving your answer to 4 decimal places. Okay, now you cannot. Let's take a look. All right, because the question asked for hands, you cannot just you know um, you cannot just use a calculator for this. Okay, so this is actually approximately this the antiderivative of ln cosine 2x over x squared dx integrating from 0 to 0.5. So this will then be equivalent to -2 0.5 minus 4 over 9 0.5 cube, okay, minus 64 over 225 0.5 to the power 5 minus 0, right? Because all terms contain 0, you will obtain negative 1.0644 to 4 decimal places. Okay, then finally, the last part of the question just says use a GC to find a second approximate value for this, giving answer to 4 decimal places. So in case you have forgotten how to use the GC, this is a quick demo. All right, now at the screen, the home screen, you just need to go for alpha window. You will see the fourth function being the integration function. You select that. Now the integration works from 0 to 0.5. Okay, and the function we are looking at is a rational function of ln cosine 2x, okay, over x squared. All right, and remember you need to integrate it with respect to x. Now, because it's trigonometry, make sure your measurement is in terms of radian, and then you can evaluate. This is the value by the GC. So this is an approximate value up to 4 decimal places. That will be negative 1.0670. Okay, to 4 decimal places. And that will end this question.